What are the processes or problems that activate programmed cell death?
What are the, a great variety of things. Anything that makes a cell uncomfortable, lack of the cytokines or the factors that help cells grow, radiation damage, chemical damage, signals from within that the cell has accumulated too much DNA damage, too much damage to its genes, and it should fall on its own sword and die for the benefit of the greater body. Many, many different signals trigger this process of cell death, and it's very important that they do so. Too much cell death can lead to a lot of degenerative diseases. So if cells decide to die when they shouldn't die, tissues degenerate. Too little cell death can lead, on the one hand, to cancer, as I've said, but also to autoimmune diseases, for example. So it's a very fundamental life process, critical for life.
Question in the middle here, middle row.
First of all, congratulations. I want to know what the research that you're focusing right now is on.
It's still on this process of apoptosis, the process by which cells die. We really want to understand at a very deep level the biochemistry that's behind that process. And we want to know how it's regulated, and we want to know how to manipulate it ourselves. What we're trying to do, and many labs around the world are trying to do the same thing, many companies around the world are trying to do the same thing, is to develop small chemicals that will trigger the process effectively in cancer cells. Because cancer cells, we treat them with radiation and chemotherapeutic drugs in order to activate this process. If we could activate it more effectively, we'd have a drug that kills the cancer cells without so much collateral damage. I think of it as trying to develop a laser gun to kill the cancer cells instead of using a blunderbuss to kill them, as we do now.
I think I can take one more question. The lady in green in the middle, yeah.
What do you think is the next enabling technology that will allow the next quantum leap?
Oh, that's a hard one. I think that I'm very in awe of the technologies that are developing in imaging. I think they're already transforming the way that we think of biological processes, giving us huge insight that we were incapable of seeing before. You know, one day I'd like to think that we could look at a cell and give a signal on the outside and then see the entire biochemical pathways light up in front of our eyes, and we could see it all happening in real time. And I think we'll get there with the kind of imaging technologies that are developing. That's my best guess. What do you think, Paul?
Oh, I think I said I wouldn't answer any questions. I want to thank Suzanne and congratulate her on this wonderful occasion. I want to thank Wafaa for making it such a special occasion, and I'd like to thank you all for coming here this evening and welcome you all to adjourn to the Abbey Lounge for a reception. Thank you all. Thank you. Thank you.